Okay, so example 10 puts together the previous couple of lessons with friction, and it tells us that there's a particle of mass 2 kilograms sliding down a slope. So let's get a diagram of my slope. So we've got 2 kilograms. It's going down, it's inclined at 30 degrees. The acceleration is 1 meter per second, and it's already said that is down the slope, 1 meter per second squared. And it asks for the coefficient of mu, friction mu, between the slope and the object. So let's start off by adding in all of the forces. So the reaction is here. If we've got friction, given that we're accelerating in this direction, we know two things. We know the friction will be in the opposite direction, and we know that it'll be at its maximum possible value. So because it's moving, friction will be trying its best to make it stop. Then we've got the weight pulling this down, which is 2g. Okay, that's my force diagram complete. So now I can go into resolving in various directions. And from the previous lesson, hopefully we're happy that to get the resultant force, we're going to resolve perpendicularly. So remember, we resolve forces in the perpendicular direction to the slope and parallel to the slope. We do not do it when we've got a slope question vertically and horizontally. So this is in the direction of r. This is r equals, because it's not going to move off the slope or it's not going to move into the slope, it's going to be balanced. So it's equal to 2g, but that 2g isn't on the perpendicular. If I put a dotted line in here, you can see that that is the perpendicular. So we're at some angle. And the way we find that angle is we think about this being a right angle triangle. We see that this is going to be 60 in here, and then we look to get that pink arrow going down, the 2g to that dotted line, we move away from the 60 degrees, and if we are moving away from the 60 degrees, then that is sine. So it's 2g sine 60. Pop that into my calculator, see what we get. 2 times 9.8 times sine 60, and I get a long decimal, but I'll do it to 5 significant figures at this stage because I know I'm going to have to use that later on, so I don't want to round it prematurely. We then resolve it going down the slope. We know it's accelerating down the slope, so I'll take that direction as positive. The only force pulling it down is our 2g, and again it's not pulling us straight down the slope, it's a 60 degree away from the slope, so I have to move through the 60 degree to get back to the slope, so that'll be 2g cos 60. Meanwhile, you're being resisted by the friction. Okay, so it's 2g cos 60 minus friction. But we know what friction is. Because it's moving, because it's accelerating, we know that friction is at its maximum value. And friction's maximum value is mu r. Right, that is the key formula from this lesson. Friction equals mu r when it's at its maximum value, when something is moving or when it's accelerating along a surface. So I've got both. I've got the r, I can substitute that in, but I've not got the mu. So actually what I'll do is I'll leave it for now and we'll put the r in our final calculation. Rather than carrying around 16.975, I'll just leave it as an r, but bear in mind I know what that is. So then we can do F equals ma. Right, we've got the 2g cos 60 minus mu r, that's the force, is equal to the mass 2 times the acceleration, which is 1. So 2g cos of 60 minus mu r is equal to 2. Now, I want to rearrange that because I want to be able to get mu. So let's rearrange it to get mu equals. And I'm not going to work out any of these numbers, even though they are numbers. I'm just going to leave it as they are from the time being. So 2g cos 60, move the 2 over, move the mu r over, and then divide by r. I know what r is, and I'll substitute it in a moment. Okay, so then once I've got to there, that's what I'm going to put into my calculator. So I'm going to do 2 times 9.8 times cos 60 minus 2, and I'm going to divide by my value of r. So going back up to where I found r in the first part, that was 16.975. So it gives me a coefficient of friction. I'll give it to 3 significant figures of 0.459. Okay, so that's a combination of the friction that we've just introduced this lesson and the previous lessons, which is resolving on a slope. Very, very important in mechanics, core ideas in this first unit, Unit 5, that we've done in the Year 2 mechanics. have a go at some of the questions now. It is exercise 5C, and I recommend that you do question 1, but just one column. There's a lot of questions, you'll see when you get there. Then question 2, all 3, they're all good practice. And then question 3 onwards, you can do all questions from there. They're the exam style, more worded. You have to draw your own diagram, and then resolve and solve them like that. Remember, when you're doing these, friction equals mu r is the key formula, and you've got 2 things you're going to do. You're going to resolve in the direction of r, and you're going to resolve in the direction of motion. And just then you're going to use F equals ma, and hopefully everything should come out from there.